Hello, welcome to my course project, Principle of Communication System. My name is Maya Reponte from BS Computer Engineering. In this video presentation, I'm going to discuss the digital modulation and its basic techniques. So, what is digital modulation? Digital modulation is the process of encoding a digital information. It provides more information capacity, high data security, quicker system availability with a great communication. There are three basic techniques of digital modulation. 1. Amplitude shift keying or ASK. Number 2. Frequency shift keying or FSK. Number 3. Phase shift keying or PSK. Okay, before we proceed to the three basic techniques of digital modulation, we're going to review what is phase, frequency, and amplitude. So what is amplitude? Amplitude is distance between the origin and the crest or the true. So as you can see here, the true is lower and the crest is higher. So you can see here the horizontal line, it's called rest position time, and the vertical line called displacement. And the wavelength is the distance between identical point or consecutive waves. Next is frequency. What is frequency? Frequency is the number of waves that pass point per unit. Example, this chart. You can see the wave passes to the time line and you determine what second, minutes the wave passed here. Phase. What is phase modulation? Phase specifies the location of a point within the wave cycle. It specifies also the angle in either degree or the radians. As you can see here on the sample chart, the phase turn at the circle. For the angle, it's turned to counterclockwise. Let's take a look at the chart. As you can see, there is a three type of modulation here: the amplitude, frequency, and phase modulation. As you can see, the amplitude modulation, it slides like a roller coaster, that not much more going to deeper the flow of data. And the frequency modulation is like up down, which means the binary 0 is lower and binary 1 is upper, binary 0 is lower, binary 1 is up. In the phase modulation, you can see it's like a matrices spring that have a gap of the electromagnetic wave that you can see. This like similar, but there is a gap on the carrier electromagnetic wave, which is having a 0 binary and lower 1 binary and 0 up binary. Data flow. Here, let's discuss digital signal. What is digital signal? Digital signal is a signal that represents data as a sequences of discrete values. As you can see here, there is a binary 1, which is higher, and binary 0, which is lower. And here down, it's called carrier signal. Carrier signal is the unmodulated single frequency electromagnetic wave that carries the desired information. You can see it's different wave of different modulation, either the frequency, pace, and amplitude. Now let's talk about amplitude shift keying, or ASK. What is amplitude shift keying? Amplitude shift keying is a modulation method where digital signal change the amplitude of the carrier. If the signal is 1, then the carrier wave amplitude the same. When the digital signal is 0, the carrier wave amplitude is much weaker. As you can see here on the chart, it shows that the binary 1 is up and the binary 0 is lower. And it showed the carrier wave amplitude is the binary 1 is higher and the binary 0 is like near on the horizontal line, which is the time or the rest area. Next is frequency shift keying, or FSK. Frequency shift keying is the modulation technique in which frequency of the carrier wave changes with digital signal. As you can see in this chart, digital data. So that is a binary 1 and binary 0. The binary 1 is the higher and the binary 0 is the lower. So the carrier wave amplitude in here, frequency shift keying, as you can see, the binary 1 is the higher, which is much closer than the binary 0, got space of the carrier wavelength. Phase shift keying, or PSK. It is a digital modulation process which transmits data by changing the pace of the constant frequency of the carrier. Let's take a look with this chart. Let's take the bottom of the chart here, the PSK signal. The frequency and amplitude carrier wave remain the same. Only change is phase. Specifically, phase change at the point where binary value is 1 and changes to binary 0, or binary value 0 changes to 1. Example number 1. We need to send data 3 bits at a time at a bit rate of 3 Mbps. The carrier frequency is 10 MHz. Calculate the number of levels, the band rate, and the BW. Solution. Here we have n is equals to 3 bits at a time, and we have the bit rate is 3 Mbps, and we have the frequency carrier, which is 10 MHz. So we need to find the number of levels, the band rate, and the bandwidth. So here we have L, which is represent the length. It equals to 2 times n over n. So it is equals to 2, and I put the value of n, and it equals to 3 bits. So it is called it will solve as 2 times 2 equals 4 times 2 equals 8. So in a rate, we have still unknown. So we find the value of rate, then it equals, use this formula, the second formula, which is R is equals to big R, which means the bit rate over N. So the value of a big R is 3 Mbps over N, which is 3 bits. It's equals to 1 M-band. And the last one is bandwidth. This is BW. So BW equals the length and the rate. It is equals to the value of length is 8 and times the rate, and it equals to megahertz. It's 8 megahertz. Example 2. We have an available BW of 100 kHz, which spans from 200 to 300 kHz. What should be carrier frequency and bit rate if we modulated our data by using FSK with D equals to 1? Here's the solution of example number 2. BW equals to 100 kHz. kHz means kilohertz. So let's proceed. BW equals 1 plus D times R plus the wavelength equals to 100. So 100 equals to 2R plus 50 equals 2R equals 50. So we have to separate have the variable so that the variable will left alone. So we have to separate it and transfer the 2. So it will be like 50 divided 2. So the value of R is equals to 25 kiloband. Next, for the level of FSK, we need to find the N value so that we can able to times here on the rate. So L is equals to 2 and equals to 2 over N, no, power to N, and N is equals to 1 bit. So it happened here. We have the value of R and we put the value of R here on the R is equals to Rn, the letter R equals to Rn, and the times to 25 times 1 and equals to R, it's 25 kbps. Thank you for watching my course project video presentation. I hope you enjoyed it. Have a good day.